Today we're answering a very popular product design question that shows up in PM interviews at top tech companies like Google, Meta, Amazon, and Microsoft, which is to design an innovative elevator. To structure my answer, I'll be using the circles framework, and as a quick refresher, the goal of the framework is to understand the question, list impacted users, narrow it down to the most important one, then list their needs, pick the most important need, and do the same for solutions until you arrive at a clear answer. With that being said though, frameworks are used as a guide, not a script. The goal isn't to check every box of the framework in chronological order, but to use it as a mental checklist to ensure that you're not overlooking key parts of the problem. With that being said, let's jump into clarifying questions before we start with the solution. First, I want to see if the interviewer has a specific direction in mind. The clarifying questions I'd ask include, what is the goal of the elevator redesign? Are we optimizing for speed, safety, accessibility, or overall experience? Where are these elevators located? Residential buildings, offices, hospitals, and if we're focusing on a specific building type, do we have any clarity on the number of people who are using the elevator each day, or the number of elevators in a building? Additionally, what role am I playing in this scenario? Am I designing an elevator for a specific company, or am I a part of the building management? Next, regarding constraints, are there any environmental or regulatory constraints like seismic activity or building regulations that I have to follow? Additionally, are we limited to a fixed budget, timeline, or technical limitations? And lastly, does a building have smart technology that the elevator can use, like sensors or a screen? Let's say the interviewer leaves these questions open-ended, which happens pretty frequently. That means we can define a lot of the goals and users ourselves based on what we believe will result in the most impact. For this walkthrough, let's assume that the interviewer lets me define the scope based on the clarifying questions we discussed. The only clarification provided was that I work directly for the building owner. That means my responsibility is to design an elevator system that keeps users happy day to day while also being reliable and efficient. I'll also assume that there are no major constraints around budget, timeline, or technical feasibility. Before I jump into the solution, feel free to pause the video here and try working through the question yourself. Great. Now that the scope of the question is set, I want to identify the users who are most impacted by elevators. I'll start by breaking them down into 4 primary user segments. First, we have daily commuters. This includes employees in high-rise office buildings and residents in apartment towers who use the elevator multiple times a day, whether they're heading to work in the morning, grabbing lunch, or returning home. Next, we have visitors and clients. This includes people who enter the building occasionally, like a guest visiting a corporate office or a patient coming to a hospital. Unlike daily commuters, they're unfamiliar with the building, and complex elevator layouts and directions can easily slow them down. Then we have the elderly and the physically challenged users. You often find them in hospitals or residential buildings. Many of these users can't easily use stairs and rely on elevators to move between floors on their own. Some use mobility aids like wheelchairs or walkers, which means elevators need to be easy to enter, navigate, and operate without assistance. And finally, we have maintenance and operation teams. This includes technicians, building engineers, and facility managers who are responsible for keeping elevators running. They interact with the system less as passengers and more as operators. They're responsible for keeping elevators running day to day, but today that often means reacting to breakdowns when they happen, manually running diagnostics to troubleshoot issues, and fragmented coordination across tenants, security teams, and building management when issues occur. Out of the user segments, I'm going to focus on daily commuters since they're the highest frequency and highest impact users for a couple of reasons. First, they interact with elevators multiple times a day, so even small inefficiencies compound quickly. A few seconds of delay on a single ride may seem minor, but multiplied across hundreds of people, dozens of trips every day, it has a meaningful impact on productivity, congestion, and how efficient the building feels overall. Additionally, from a building management perspective, daily commuters matter because their day-to-day experience shapes how companies view their building. Elevator shortcomings will often surface in tenant complaints and renewal discussions. Efficient elevators reduce that friction and make the building easier to operate and retain tenants. Next, because daily commuters also ride elevators multiple times a day, the volume of their usage creates strong, reliable signals about system performance, making it easier to identify issues like wait times and congestion, and we can optimize accordingly with this information. And lastly, for the daily commuter user group, there's often overlap with other groups like visitors or clients. Think about a mixed-use building. Employees work there every day, but those same elevators are also used by guests coming in for meetings or lunch. So if we make the system faster and more predictable for commuters, we're also helping other user groups too. Next, I want to identify a commuter's core needs. I'm first going to break down their end-to-end elevator journey and see where friction shows up. For a typical daily commuter, their journey looks like this. First, they decide their destination, they call the elevator, they wait for the elevator to arrive, they enter the elevator and select their floor, they wait in the elevator while riding, they exit the elevator, and finally they head to their destination. Because these users are daily commuters, they're already familiar with how the elevator system works. The key insight here from the user journey is that the pain point isn't confusion, it's waiting. As the journey shows, waiting happens twice, once before entering the elevator and once while riding it. Reducing either of these waits can significantly improve the overall experience, which gives us the first pain point. At the same time, commuters understand that elevators aren't teleportation devices, and some waiting is inevitable. What makes waiting especially frustrating is unpredictability. When they don't know how long the wait is, the experience can feel even worse. Because waiting is already frustrating, that frustration is amplified when elevators are overcrowded, resulting in commuters to skip a full elevator and wait for the next one. Additionally, once commuters are inside the elevator, frequent stops on multiple floors make the ride feel even slower, adding to more frustration. Next, commuters sometimes have to go to different floors for meetings, client lunches, to the gym, or other amenities, and going to the wrong floor wastes time and adds stress. They want confidence that they're heading to the right floor. And lastly, commuters value a clean, touch-free experience since shared buttons and tight spaces can feel uncomfortable or unhygienic, especially after the pandemic. Looking across these needs, reducing wait time stands out as a foundational problem to solve. When wait times are reduced, we also address the other pain points as well, since elevators will be less crowded, commuters are less likely to skip full cars, and rides involve fewer stops. Transparency will also become less important when wait times are already short and reliable. Solving the problem of wait times creates a ripple effect that makes the entire elevator system better, resulting in happier users. With the most pressing issue pinpointed, let's move on to brainstorming some solutions. The first idea is a digital lobby display. These would be screens near the elevator banks that show estimated wait times and clearly indicate which elevator is arriving next. Even when a wait is unavoidable, setting expectations can help reduce frustration. The second idea I have is an AI-driven traffic optimization system. This feature uses historical data to learn about traffic patterns to better balance demand across all elevator banks. For example, the system might learn that between 8:30 a.m. and 9:15 a.m., most commuters are traveling from the lobby to floor 20. During that window, it can proactively send elevators to the lobby. And the third idea I have is auto-assigned elevators. This connects the elevator system to badge scans and meeting schedules so the elevator knows where someone is going before they press a button. As you walk towards the elevator bank, a screen shows that elevator B has already been assigned to you and is headed to the floor where you have your 9 a.m. meeting. You step in, the doors close, and the elevator takes you up there automatically. Now for each of the solutions I listed, I want to evaluate the trade-offs and comment on each solution's impact versus effort. Starting off with the digital lobby displays, this solution improves transparency, but they can unintentionally create new bottlenecks. When a screen highlights the next arriving elevator, people will naturally cluster around that car. However, now this car is super crowded, and it'll result in the car stopping more often since there's more people. Then let's say there's another elevator coming shortly after. Because everyone already onboarded the first elevator car, this one will have nobody in it. This solution improves wait time perception, but doesn't actually improve the wait time, which is why this is a low effort, low impact solution. This solution is relatively quick to roll out and improve transparency, but they don't actually change how the elevator system operates. Because they don't reduce wait times, they fall short of addressing the daily commuter's most pressing need. Next, for the AI-driven traffic allocation solution, it can struggle when real life doesn't follow past patterns. If the system relies too heavily on historical data, it may perform well on typical days, but break down during unexpected situations like bad weather or schedule changes. When elevators unexpectedly skip floors, wait longer to group riders, or behave in ways that users don't expect, people may assume that something is wrong even if the system is technically working as intended. Over time, that loss of trust makes the system feel slower and less reliable, regardless of how optimized it actually is. This is why it is a medium effort, medium impact solution. When tuned well, it meaningfully reduces wait times, but it requires high-quality data, constant iteration, and guardrails to prevent edge cases where optimization helps some users while hurting others. And lastly, for the auto-assigned elevators feature, this may feel magical when they work, but very fragile when they don't. The system relies on signals like badge scans and calendar syncs, and if this integration isn't complete, this feature will not be effective. Additionally, meetings get rescheduled, people arrive early, or plans change last minute. When predictions are wrong, elevators will move unnecessarily, wasting capacity and slowing everyone else down. Another trade-off is loss of user control. When elevators are auto-assigned, commuters may feel confused or uncomfortable if they are sent to an elevator without clearly understanding why. If the system makes a wrong assumption, users don't have an obvious way to correct it, which can lead to more frustration and mistrust. For a daily commuter who values speed and predictability, even a small loss of control can outweigh the convenience it may provide. This means that auto-assigned elevators are a high-effort, medium-impact solution. Making them work well requires deep integration with building systems, highly accurate data, and thoughtful design around privacy and user trust. The system also needs to clearly show users which elevator is assigned to them and easily allow overrides when predictions go wrong. Without these guardrails and a complete rollout, the experience can quickly feel confusing or unreliable, which limits the impact despite the significant effort required. With that being said, no single solution fully solves the problem on its own, but AI-driven traffic allocation strikes the best balance between impact and effort, while directly fixing the core problem of wait times. However, as mentioned earlier, there are some pitfalls to the solution. To make sure that this solution delivers real value without introducing new problems, I'd add a few guardrails. First, I set a minimum service guarantee so no floor is ignored, even during peak traffic. For example, every floor should get an elevator within a set time, like 90 seconds, no matter how busy the building is. Secondly, I'd have the system reevaluate traffic often, like every 30 to 60 seconds, rather than relying on historical assumptions. Finally, I'd give building management clear override controls for edge cases like maintenance, fire drills, or special events. I'd roll this feature out incrementally. This allows us to prove real impact, refine the system under real-world conditions, and scale only once we're confident it measurably improves the commuter experience. And that wraps up my solution for this problem. Let me know if you have any feedback on the series or like me to cover any other mock interview questions. See you in the next one.